had two of them, but the panel is on why a superpowered systems engineering is crucial in tomorrow's world. Now, I've just got a few seed questions to get the atmosphere going and get you energized, but the whole idea is that audience participation. We're not here for mini presentations, we want the interaction. So I believe there's a couple of mics around the room. When you want to ask a question, please introduce your name and your current employer, okay? Don't need a bio or anything like that. So, and the other thing is, I am going to be harsh if you're an individual that likes to come up and talk before they even get to the question. So I will be saying, can you please move on, what is the question? So, so anyone that likes to hug the mic, beware, I am watching and listening. Okay, so let's just start off with the panel. Okay, there's me. I think you all know me by now. I'm a past president of CISA and INCOSI and sector director, and I work for Thales at this that stage. So we'll move on. You all heard Mike, so I will not introduce him again. And the lovely Katina we just heard, but I will just spend a minute to introduce Stephen. You haven't heard him yet, but he is the director of the National Energy Analysis Centre, which Thomas mentioned in his presentation at CSIRO, Australia's National Science Agency. Stephen has more than 25 years of experience in applied research, strategy, development, and commercial innovations in systems engineering, digital technologies, and communications. So, so we've got a great packed stage of very informed and love to communicate their knowledge on this topic. So the topic is on why a superpowered systems engineering is crucial in tomorrow's world. So let's just, I'll leave that up as the background. So think of tomorrow's world. We've had quite a few examples this morning. So speed of change, they've got the digitalization happening, the use of AI, virtual reality, modeling and simulation, autonomy, data sciences, managing the data. There's so much that we can consider going forward. 3D, manufacturing, different development life cycles, good old historical ones, incremental, evolutionary, lean, agile. You read another book and someone's come up with a different development life cycle to suit. So, and we're in that position to pay attention to all of this. So I might ask the first question, but keep in mind, again, the topic, why a superpower of systems engineering is crucial in tomorrow's world. So hopefully I've set the scene. So I might ask the first question around systems of systems and maybe direct it to Michael. So systems of systems, if you're not familiar with them, are generally made up of other systems that have been operate independently initially, developed in a different life cycle. They're at different stages of their life cycle, generally governed by a different set of framework structures, standards, etc. But all of a sudden now they've all got to start working together. So now when you start thinking of all of adding in the extra tools and applications and the way we do work going forward, Michael, how do you see that we can handle these systems of systems complexities?
That's a really good question, Kerry. You know, system of systems embodies a number of challenges. In the context that I usually see system of systems implemented, it has to do with systems that were developed independently with different objectives and then work in combination to achieve a different objective than perhaps what they were originally designed for. That requires a number of things. It requires communication. And so it brings in the social element very strongly. How do you work across, if you put it in the military context, how does the Navy work with the Air Force, work with the Army? How do you work across that? What communication norms are different? If you're working multinationally, how do you communicate culturally? What does that look like? Because that is part of what you're trying to do with your system of systems. is you're trying to integrate things that have a very broad base. I used to tell people with my work at NASA that if I get the physics wrong, the rocket will blow up on its way to orbit. If I get the social constructs wrong, I'll never get the rocket to the pad, I'll never build it. And the system of systems really embodies that, is how do we work together across different domains, across different types of systems, across different cultures, to bring about something that achieves a much broader, much bigger example with that.
Thank you. Anyone else like to comment on that? Okay, still haven't warmed you up, so let's think of another question. I might direct this at Steve on circular economy. If you're in delivering projects at the moment, and depending if your company has signed up to different agreements, I know I look after the eco-design in Thales, Australia, so I have a lot of reporting to do on what are we doing with sustainability, carbon neutralisation, circular economy with recycling, deconstruction, etc. So what do you think, Michael, Stephen, we're in a position as systems engineers, we get to look at the whole product life cycle. So what can we do differently or better to improve how we can be part of this circular economy, taking into considerations, is there anything we need to do differently at the beginning to take into the considerations like carbon neutrality, recycling, deconstruction? We often didn't pay attention to that, particularly to the retirement of a system or a product. So what can we do? What superpower can we take hold of?
Superpower, yeah. Hi everyone. Great to be back at SETI, and thanks for the question, Kerry. So I think, like Katina said, we cannot ignore the planet, and increasingly the expectations on us are that we do not ignore the planet, and we see that in regulations, in ESG frameworks, environment, social governance frameworks from investors, from shareholders. So there's sort of that formal expectation that we do consider these aspects, that we draw our system boundaries wide enough to consider environmental considerations up front. I also think there's a generational aspect. A lot of the environmental questions are about future generations, and if you ask your children, if I ask my 19-year-old if I can skip that environmental stuff and what I do, I know what answer I'm going to get. So definitely, we operate in a societal context, and in that society, these aspects are more and more important, and we do need to consider them, I think, as a systems community up front. The other reflection is that these types of problems, waste, climate, energy, are not owned by any single organisation. They cut across nations, they cut across levels of government, they cut across organisations in the private sector. So there is no single entity that can solve it. The only way it can get solved is through distributed action. And as the question was posed, we have a real opportunity in the systems community to act ourselves in designing new systems to improve these areas. We also have an opportunity, I think, to drive coherency and synergies between actors across this distributed system of systems to achieve greater outcomes overall.
Comment from any of the other panelists?
I concur with Michael and Stephen. The boundaries used to be well defined. You could say this was your system in the past. Think about it. It was just, when we talked about socio-technical systems, it was the department in the organisation. It wasn't even the organisation. And as we built technologies that enabled that communication, those transactions of exchange, we started to see our boundaries drifting. And so what we talk about today is like more open systems, and the systems connecting with other systems form ecosystems, and stakeholders in those ecosystems could be direct or indirect, operational or non-operational, and a competitor could be a collaborator in the future. But the systems we're seeing today are highly meshed and entangled. It's not clean like the 1970s when we had transaction processing. We've developed and we've opened up our border and our boundaries, and in so doing, the complexity has rushed in. That's one aspect. But I think as well the adaptive nature as the environment, a great example that Stephen just gave, is constantly changing out there. We're not monitoring the temperature right now, right? We're not discrete. We're analog beings. Things are changing. Even while we're sitting here, the news is telling us different things about what's going on around in the world. We can deploy agents to sense those things in the environment and to give us feedback, like the opening slide that we saw from Thomas on what is systems thinking. Those feedback loops, control mechanisms, change. We have to become more agile in our organizations and deploy systems and agents that are actually collecting meaningful data, not data because the node can just collect it. Many of the machine learning projects I did in the States, we always got free data from the big tech companies that we couldn't use because they meant nothing. When are we going to start collecting meaningful data in the nodes that can help us adapt, but do it automatically where required? So my question to you is, the world's adapting, how are we capturing that change? It's moving fast, it always was and always is, and our technology is propelling that. But while we're sitting down at the conference, how do we make decisions when we're not always on the pulse?
Can I add a little bit?
Yes.
Yeah, so what's the definition of a system? A system is the interaction of the subsystems, the systems that support it, and the environment. And a lot of times you look at studies in school, perhaps you don't consider the environment. But if you're not considering the environment that the system is operating in, then you're actually considering the system. You're treating the system as a subsystem. And one of the key things to work in space is you have to consider the environment. You can't land on the surface of the moon without considering the environment. And so it's a key element of systems engineering is to make sure you understand what are the impacts of the environment. Does the system itself in producing the material to build that system, does it create an ecological problem? That's part of our job, to know that and to say, maybe we should pick a different material. Maybe we should include what's necessary to prevent that. And that's part of the role of systems engineering.
Any questions on the floor? Oh, yes, we have one. Thank you. Don't forget your name and where you're from.
All right, so can you hear me? Okay, yeah. Paul Pierce, BAE Systems. It's hard not to be moved by the presentation we heard before by Dr. Katina. Thank you. Keeping this question at the macro level, those really big socio-technical problems that this world's clearly facing. What are your insights? I'm actually asking the panel, what are your insights in terms of how we retain that human core, that human element, that maintain control and some degree of accountability for what's going on and how we respond to the challenges that we face?
Maybe I can start and talk about some of the work that we do at the National Energy Analysis Centre focused on the energy transition, and that is being very much putting the human at the centre and seeing energy as a means to an end, a means to a societal end. And so when we look at the data and do the analysis, we're not talking about, oh, it's a network load. It's a father cooking dinner for his daughter. It's an industry producing an industrial output. So really putting the human in whatever context at the centre and seeing energy as a means to that, and having a systems engineering framework that recognises that central place of the human and the human endeavour.
Yeah, AI is a real challenge in how we're using it. And Katina, I thought, really brought it out extremely well in her talk. We are responsible for the application of AI. AI is a tool. And I've talked to people and they're like, they treat AI like a person. It is not. And Katina really, really brought that out extremely well. We are responsible for the results of the AI. When you look at the AI and the result that it gives you, it's not responsible for the errors. You are, if you take them and use them. And you have to be discerning. And you also have to remember that you have that responsibility. You cannot defer it. It is your responsibility. Just as if you were running a MATLAB code or running a Cameo model, you are responsible for that.
It's interesting. I know that it's not a person, but I still can't help yelling at it at times, just like I do with the GPS when I don't like the answer and I'm not getting any closer to where I want to be. And then I think, oh, Kerry, calm down, walk away. We have a question at the back of the next. Is the one to go? Yes, Grace.
Hi, it's Grace Kennedy from Academia. I saw on the slide that you had a quote from Drucker, and he was saying that we're using yesterday's techniques. I was wondering whether there's actually an issue that we're also solving yesterday's problems. And today's world, our macro system is very much aimed at the reactionary, kind of short-term thinking and solving yesterday's problems. So my question actually is, what does the systems engineering superpower look like if we're to move towards more proactive and long-term problem solving? Thanks.
Tina, I think that you'll start that one.
Thank you, Grace, for that great question. I agree with you. We talk a lot about anticipation today and foresight planning and scenario-based planning. And I think when you start seeing conferences called Anticipation or the Possibility Studies Network Conference, which I've been to at Cambridge Uni, you start to see that some of these things are actually happening. Oxford University, for example, famous for its scenario planning, and one of my colleagues there, Cynthia Selim, who's championed those scenarios, they are embedded. And you could say to me, we've always done that in systems engineering. We've done the best case, the worst case, and the average case. I get it. I used to do that with the telecommunications forecasting in business cases, but we're talking about something different here. And the better we anticipate doesn't mean we have everything. We have to learn to work with ambiguity better. And I know engineers and mathematicians hate assumptions. Show me the evidence, show me the data, I want to know what that answer is. And the more you go into Asia, the more you realize they want to know the answer to the nth decimal place. It doesn't exist today. We don't have complete transparency or visibility, though we've got to strive for that visibility. But ambiguity is what is occurring, and we have to learn to work with ambiguity as engineers. We're not comfortable with ambiguity or vagueness or abstraction to an extent. But I would say, Grace, it's to anticipate, it's to do more scenarios, and to look at risk, particularly cybersecurity, where we can see the red teaming concepts. Just because we're doing AI, it doesn't mean no one's going to try to attack you. We've seen what Claude Mythos just announced recently with saying we're not going to give you this, everybody, because it would let you bust into organizations. They discovered 1,000 zero-day attacks of some of the world's largest banks and big tech organizations, your Microsofts, your operating systems, things that hadn't been disclosed. So how do we use that to our advantage to do more scenario planning, especially for climate change?
Yeah, so I think that exploration of alternate futures and being very deliberate about that, transparent about the uncertainties that are there, but also combine that with the learning loops. Actually, time to insight has to be faster than it's traditionally been, and the ability to adapt and learn from what's actually happening in society and combine those two, I think is one powerful technique.
I think we might have the next question, and perhaps Michael, you might be the first couple.
Michael Hall from Thales. So a lot of the problems we have are very complex, and a lot of people don't understand the complexity, so it makes the messaging harder. How do we get to the point where we can improve the messaging and get it to a level that enables the changes that we can see?
Michael?
All right. That's a really good question. It gets into a little bit for me in the sociology of systems engineering. And terminology is a really key element of that. There was a paper written in the 1940s about why sociology wasn't coming into its own discipline very well. And one of the things cited was the lack of common terminology. That you read one paper and it said this about a topic, and you read another paper and it used the same term to mean something exactly the opposite. And it said that hindered the growth of the discipline. And so when we look at systems engineering, we're looking across a whole lot of different disciplines. You're not going to take the mechanical engineering team and tell them that they have to use gamma in some different way than what they've been taught to do in their engineering career. That discipline is 200 years old in terms of when it became a formal engineering discipline. So you're not going to change that terminology. So you have to translate. You have to communicate between the disciplines, make sure everybody understands. I mean, I've been in meetings where two different teams were talking using the same terms to mean two different things. And if you don't catch that, you see quick divergence, and you see impacts, cost impacts, budget impacts, and system development. And so it's really key to do that. Then add in a multicultural dimension when you work across countries. That becomes even more important to make sure that the subtle meanings are actually captured, because that could mean somebody's reading something different than what you're intending. And then if you throw in AI just on top of all that, which is very literal when you use that tool, terminology becomes critical for that, because depending on the terms that you use, you get different answers. And so how do you know what is the right terms to do? And I've not used AI enough to really understand that yet. I'm still learning it, so.
Comment from anyone else? All right, we've got a question at the back there.
Thanks, Kerry, and appreciate this morning session that's got me thinking completely off the planet here. So, and the comment and then a question. So the comment is, when we think of systems as an implicit sort of almost we're creating a boundary and we're thinking of it as a part as opposed to interactions. And I'm just wondering whether we need to relabel that and more focus on the concept of emergence in a sense. For example, we call ecosystems because really we can't put a boundary around it. We just say that's an ecosystem and it's got emergence happening. And what's driving that, I think, like you hinted at this, is that things are changing. Actually, Katina did as did Stephen, but things are changing so fast. So, is the superpower in a sense improving our abilities to perceive much quicker, to comprehend what we're perceiving, and then to project, to look at the options so that we can make informed decisions in a much more fluffy or an emergent construct? And if that's the case, what are we lacking? How do we improve our ability to perceive, our ability to comprehend, and our ability to project more quicker than we can in our current context, so we can actually build the systems and have them do what we want to do from an integrity perspective going forward as we evolve so quickly?
I can start. Yeah, I think that's right, JB. Certainly, working with energy, it touches everything. And so your description of the challenge, I think, is absolutely right. So a couple of thoughts there. One is just cognitive diversity, to bring the different disciplines and domains into the one room and use that diversity of experience and the diversity of skill to address this complex, connected challenge from multiple perspectives, I think is incredibly important. And something that we're trying to do through the natural energy analysis.
I think we've got time for a couple more questions. So you're next, yes?
Thanks. Peter Moore, Intelligent Systems. There's a lot of focus on AI being helping us to solve problems out in the industry. I guess I look at an AI, it's just a tool, and there's also the process and the people aspects of it. What are we doing to help systems engineers develop the people side, how to use it better, and the process side, how should we use it, particularly from a discipline point of view?
We'll start with Mike and then continue.
Yeah, no, that's a good question. So at Incosi, we've developed some AI policy. Kerry was actually part of that team. And so we're trying to get that voted on by the board, and then we'll publish that out. It's really important to understand responsibilities and the appropriate use of AI. And so we're looking at how to do that. Our artificial intelligence working group would be a great place to then engage with, talk about more practical applications of AI. As I said, Kerry and I were talking about it last night. AI is changing so fast that by the time you publish something, it's already moved past it. And so there are new aspects that we've learned or realized, or new uses that have required something additional to be addressed that it's constantly changing. So it's a really good question, and how do we address the AI? And I think we're still learning at this point. So. Yeah, I think so. I think the use of AI requires its own skills. I think Katina really laid it out really well. And I think it requires a certain ability and a certain mindset to come in and how to use it appropriately, and not get carried away by hallucinations, for example. And so that'll be an important part of what we need to do, yes.
It's a great question. AI touches every aspect of society, and in an organization, unlike previous technologies, which might have impacted finance or impacted HR, this permeates the whole organization, because in essence, when it's breaking down functions, breaking down silos, breaking down decisions between entities in the organization and between partner organizations. It's like when you're watering your soil or your garden, it's permeating every aspect of the soil. It's not just one part of it, the top layer. Really important is that you don't run away from it. So in universities, in our new degree on MBA Technology and Digital Strategy, that's why we've got AI readiness and AI fluency as one of the goals. You need to focus on it. You need to immerse students. Sydney Uni doesn't run away and say, don't use AI. We have secure exams, but then we have the insecure exams. And those that are not secured, you can use AI, not to plagiarize, but to support and complement your critical thinking, your sparring. It's called co-intelligence. We would be doing a disservice to our graduates if we were saying, forget about it, you're not allowed to use it at university. At ASU, we built whole curriculums driven by AI. The whole subject could have been called prompt engineering, very innovative terms and titles at ASU, because the president there, Michael Crow, understands education from a completely different mindset to traditional universities. He's gone to the extreme and invited in OpenAI into almost every aspect of university education. Now, I'll qualify that by saying the following. AI is not alone. If you look at Australia's DISA, 7 critical emerging technologies, there are another 6, like biotechnology, quantum, sensing, remote tech, automation, blah, blah, right? So why are they there? AI enables convergence. Don't just think AI, think geographic information systems enabled by AI. Think that way. Knowledge graphs with AI. Think differently about convergence. Don't think disciplines and silos. Break those down in your mind.
Noting the time, there is 2 gentlemen standing up. We'll just take these last 2 questions and we'll try and keep the short response, short question, in fact. You were first.
Hi, I'm Lachlan from Nova Systems. I like Katina's point about when you can't stay on the pulse, how do you make decisions? So, when there's lots of uncertainties, what do you look for when you're making a leap?
It's not that I don't want to answer the question, but it's operationalizing principles. It's not saying at the policies and principles, it's actually operationalizing that whole process. We're good at talking principles, we're really bad at operationalizing, and I think that's where the answer lies. But I'd love to share the floor with my colleagues.
No, I would agree with that, and breaking down the problem or the decision into smaller pieces and ensure that we build in a learning loop at the same time.
Okay, and we'll just take the last question.
This one comes from Sci-Fi Systems. This question is for Professor Katina. So you brought up this new sort of domain of systems engineering of public interest technology. I think many might argue that the development of AI technology has been done largely without consideration of that domain. At what point do you think the socio-technical debt of that becomes irreversible, and have we already passed that point?
I'm a cautious optimist, not a doomsdayer or naysayer. I preamble that response. That's a top question. Years ago, we were worried that a president had access to a bag that had a button in it that could actually, you know better than me on this, Michael, forgive my history, but could launch a nuclear war, for example. The Cuban crisis was an example. Way before my time, might I add. But at what level will we see us give away the power of that decision? And some might argue, but hang on a second, I'd probably want to outsource it to the AI than the president, in whichever country we're talking about, right? Or anywhere in the world. This is very interesting. But where I think I'm going to start getting really worried personally is where I say to my kids, hey, have a bit of silicon to eat. I can't see any flowers out there or food for you to eat. Go to the silicon. But is the silicon going to help us? Can you drink silicon? Clean water, good sun, food. In the end, we're going to start panicking when any of these very important things that keep us alive start to fray, and fray at a scale. We're going to say, oh, we didn't see it coming. Back to Grace's anticipation. But that's when I'm going to get worried, but it's too late at that point. That's why a lot of countries are investing, like China is investing hugely in looking at how to make their deserts come alive with new techniques to enable arable land to feed their country, right? So we have to think way before that, like that Japanese tale that I hope you'll never forget. 400 years from now, what will our water and river systems look like? What will our natural settings look like? And in the One Basin CRC, we call it a basin-led approach. It's not even a human-centered approach. Our First Nations people, with their wisdom and knowledges of the ancient times, they talked about a basin-led inquiry, country-led inquiry. They know what's happening. They get it. Apart from the fact that now we've given legal entity to river systems, like in the Margaret's River. Some of our rivers have a right to be alive in our legislation. Have a look in Western Australia. So when we start to acknowledge that life is more than just us, despite that I still talk about humanity-centered design, inclusive of humans and nature, I think I'll worry if I see these disappearing.